VVT is the most common acronym for variable valve timing. That's basically, if you go back to the old engine builders, one of the things they'd learned is to make more torque, you could advance the camshaft. They'd move the intake closing point earlier, and that would trap more cylinder pressure and make the cam act a little bit smaller. If you need to make more power at high RPM, you retard the camshaft. By retarding the camshaft, you move the intake closing back later. That moves the power band higher. So they could tweak the power curve by either advancing or retarding it. So variable valve timing system is basically any system to vary the valve timing. The most common ones are with the cam phasers, and what they do is advance or retard the camshaft, either for peak performance at wide open throttle or to be able to, for peak economy, by retarding the cam under part throttle load. If you're sitting at my desk, then you start scratching your head and go, hey, here's this cool thing where the computer can move the cam around where I want. How do I take that and make more power? And that's where the whole idea of phaser limiters came in. Trying to limit the movement of the camshaft to a more precise range, then take advantage of that smaller range and put the camshaft exactly where you want to go. The phaser limiters allowed us to put a much larger camshaft in. We'd run over a smaller range. Instead of running over a 50 or 60 degree window, we'd run just over a 20 degree window. And probably only really use about 14 degrees is what most of the tuners will use. And basically it lets you put the camshaft in about 7 to 14 degrees ahead and then back it up, and use that at low RPM, usually coming in around 3,500 RPM, and then back the camshaft up to zero advance or maybe a slight retard. If you look at any of the motors that we've dealt with, from the 3-valve Ford to the LS motors to the Coyote motors, we've seen where, compared to locking the camshafts in a fixed position to enabling the VVT, picks up approximately 15 foot-pounds at low RPM and approximately 15 horsepower at very high RPM. Now, if you're only going to operate your engine in 1,000 or 2,000 RPM, there's really not a big advantage of variable valve timing. But on a street car where you're going from 2,500 up to almost 7,000 RPM, there are tremendous gains to be made on the ends of your torque curve by going to variable valve timing.